And we are live. Hello everyone and welcome to today's Blender live stream where I'm going to be trying to be making the Loki timeline collapse effect from the latest episode. Now, this won't contain spoilers, I don't think, just it'll show the effect. Which, if you don't know, the effect is basically turning a model into spaghetti or something along those lines, where a bunch of lines emit from the object and then it spreads over the entire object while still having the same color as the main object. So that's what I want to make. I want to make it so that stuff spawns, the lines spawn from the object, but keeps the color and all that, and the age of the particle works and everything like that. So that is the plan. So let's get started. First thing that I want to do is I'm going to decimate this model just so that this will run in real time. Let me change the frame rate to 30 frames per second to match the live stream. So let's set this to be, instead of 7,000 polygons, let's reduce it so that it's quite a bit less. I think, yeah, that's good enough for now. Let's go with 2,500 just for speed. And then we need to make it so that a gradient appears and spreads over this object. Now we can do this in multiple ways. We can do this just by having, let's have it start at the hand and then move along. I can use the shortest paths node to animate a gradient, or I can have it so that it's a more simulated effect where a gradient blurs and then spreads over the object completely naturally. But I think I'm going to go with the shortest path method first. So let's do that. Let's get the shortest edge paths node, and then the end vertex we're going to use the group. This is just so that we get a very stable gradient that we can animate. So here we want the edge cost to be 1, and here we should see that we have a very bright gradient that I need to go and divide by so that we can see, yep, that's the gradient that we will be working with. So I'm going to animate this gradient and then store it as a named attribute so that the particle simulation can reference it. So here, let's go and add to this, and I'm going to be using, a color ramp. Yes, let's use a color ramp so that we can make it high and then low. We just want one area to be bright at once. Let's bring this back down. So I don't want it to be quite like this because that's way too little. Let's go and divide this gradient by a bit. Maybe like 2 or 3. I just want it to be enough so that the particles can spawn in without it looking way too drastic. But there we go. And then we can store this as our spawn gradient, so S gradient. Oop. There we go. So that should be good, and we can reference that in the shader editor if we want, just to debug. But yes, let's go and animate this. So I'm just going to use the viewer for convenience sake. Let's go and keyframe this so that it starts off at the hand. So just keyframe that. Move this over to like 200 frames. I want this to be slow. So here, let's go and do that. That's rather good. Let me switch this to be linear. So if we look at this, we should see it traveling over it in an okay way. If we switch this to ease, is that any better? I don't like how it has that kind of stepping motion, so we could just go in and divide this by even more to make it spread. I think that should be fine. I think so. I'm just going to be using a greater than in order to spawn the particles. So that should be good. Let's go and put this into a frame. Let's move this over to here and this over to here. There we go. So this will be our spawn gradient. Oops, I clicked the wrong key. Gradient. Let's go and put this over to here. So that's all that we need for the main object. Let me go over to the shader editor here, make a new one for our object here, and reference the attribute. I'm using Blender 4.1 at the moment, but 3.6 will probably work for everything I am doing here. Let's put the S gradient, spawn gradient, as our viewed attribute, so now we can see it in the shader editor. Actually, okay, I did this wrong, and I'm going to amend that. Well, I think I might want... Yeah, okay. We don't need to change anything that we've done, but I'm going to have another gradient here, which will just be the gradient before the color ramp. This will be so that we can change the alpha of the object to 0 as it goes along. So we can do that, and then, rather than recalculate the shortest path and all of that, we can just reference the gradient, put it through a color ramp, and that should be good. So just for speed, again, just doing this. Okay, so there we go. That's just going to be for our alpha gradient. And then this is our spawn gradient. So spawn gradient, let's put this over to here. And then, there we go. So that's good. Now we have the first part set up. Now we can go and start the actual particle system, the simulation node step. I'm going to save this just in case. I'm going to start out with just a plane, just because. And let's add in a new simulation zone right here. We're not going to be using the original geometry, so I'm just going to delete that for the time being. And what we want to do is drag the body mesh into here, and then use a distribute points on faces node. Oop. Nope. Distribute points on faces. Distribute. Yes, there we go. So here, if we just take a look at the output on our plane object, we can see that points are being spawned in. We want quite a few, but we want to reference our gradient attribute, the spawn gradient, and use a greater than to determine where these will appear. So if we let this play, we can see that those are spawning in, and then it fades out. Now the density I also need to control, so I'll use the poison disk method, I believe that's called, and then plug this into the density factor. I'm not sure if we want the density to be completely even, but we'll see about that. I think, yes, I think that's good enough for what we need. I may change that later, but for now, it's good. Okay. There we go, let's put that there, and now we need to add these particles into our system. But we may need to do some cool stuff to make them strings, but we'll get to that in a moment. First of all, just to showcase this, if we join that geometry into the simulation every single frame, we can see that the particles will still exist. They'll keep existing for the entire time, and they will not be deleted. So that's good in our case, but we need to convert these into strings for the timeline collapse, like unraveling effect. So to do that, that should be fairly simple. We just need to instance on points, and then realize instances. So realize instances right here. I should label this as spawn points. There we go. And we need to instance a very, very small curve. So let's do curve line. And then we want to make this extremely small. Extremely small. So that should be good. So if we do this, we should see right here that, yes, the curves are spawning in and they're really, really small. So that's good. Then we join that into the fold and we should see that that's working as intended. Good. Now, the next part that we want to do, let me label this once again. Be sure to always label the your little frames here. So curve on points. Let's go and move that over. We want to now offset these curves, but not the start point, only the end point. And then we're going to resample the curves. So this is where it gets interesting. Let's yes, set position node. Sorry, I lost my train of thought for a second here. And you want this to not be the start points. There we go. So here we have that, which let's just offset it up by 0.1 meter every single frame. We can see that this starts happening, which is good. And now we can make this be noise or whatever we want. I may use velocity eventually, but I think this is good for now. So we can see that part is doing kind of what it intends, and this is a cool effect. But maybe not the one that we are going for. Okay. So I may put in some safeguards later, but I think we should be good for now. Let's have some noise displacement. This will not work until we resample the curve, but I just want this to be input. Actually, no. Let's resample the curve right now. So let's resample the curve, but we want this to be by the length. So let's turn off the offset. So every 0.1 meters, I'll change this to 0.5, just so that we don't crash if it gets too wild. Every 0.5 meters, there will be another point that's spawned in. So let's put in our noise turbulence. We can use a subtract by 0.5. I could turn off the normalize, but this method works in like 3.6, so it should be fine. Let's go and put this right here, set to 0.01. So now, oh, I think the resample is too small. Ah, okay. So if we do this, we should see that the noise is working, but we still need to resample it. Even though that looks very, very cool. Not bad. And another thing that I just forgot. We need to change the seed every single frame for this. For the distribute points on faces, so that we can see, yes, much more visible lines are appearing. There we go. That's much better. Before, all of them were appearing in the same places when there was extra coverage. Okay, so now for you, let's change the count to like 1000. So instead of length, let's go by count and see if that works better. Oh, that is lovely. That is lovely. Incredibly laggy. I love it. So it's working, but laggy as all hell. So let's go and change that to 200 density. Okay. Not as bad. It's working. And they're all spawning. So this is actually good. Because since I have it as a count, that means that will always be the same speed and it can't get exponentially worse. If the splines get bigger, if the curves get bigger. So let's go and collapse this. We need to, I think we need to implement velocity. Even though I was kind of hoping that we won't have to. But that'll lead to better curves rather than these really static versions of it. So let's, I think we need to reduce the amount of resolution in those. So two things that we need to add in. Velocity and age. And age parameters so that the old splines get deleted. So which should we do first? Let's do the velocity first. So this should be fairly simple. We just need to store a named attribute, which is our velocity, and then put that into our offset right there. So vector, let's label this vel for velocity. We need to have the velocity add into itself every single frame. And then put our noise offset into the velocity right there. I know this is complicated, but bear with me. There we go. So that is our applied velocity. We want it to not be on that part, which may lead to a few little errors later on, but I'm good with that for now. And then we just need to scale the input velocity for some drag. So just like that. And now we should see a lot more spaghettification. Why is... Okay. So it's a lot more wild, which we can tone down how wild it appears to be. Maybe 0.5. Maybe we want the noise to be a bit more varied. We could also have it so that the curves want to go away from the normal of the object. Not entirely sure though. But since we have the velocity enabled, so let's have this as apply velocity. I'm going to move you and you out of here. Just out of the group real quick. Just for clarification. There we go. This will be not start point. There we go. This will be old velocity. There we go. So now for our age parameter, we need to implement that. So here, this is extremely simple. We're going to store an age value on the spline domain, which means it will be faster because it's calculating per spline instead of for every point on the spline. Just a little optimization right there. If we do that, that'll work well. Just so that it updates by 1 every single frame. So on frame 1, it will have an age of 1, and on age 50, it will have an age of 50. We're making a particle system right now, so this is everything that's needed. So age, and then we need to delete it if it gets too old. Just like real life. Let's put this as a spline, and then have age, and then make it so that if the age is greater than, I'll do 50 frames, it will delete. Again, on the spline domain for speed. So let's go and do that. So this will just be delete. There we go. So now if we do this, we should see that the splines disappear once they get too old. Which we probably want to extend the lifespan of this, but it should be fine for now. Because one of the next things that we need to do is we need to go and we need to mesh the curves. There we go. So to mesh the curves, this should be fairly straightforward. Curve to mesh, put that into here, and we want this to be a curved circle. Oh, this was a mistake. Let's set it so that it's 0.01, so that they are extremely thin. And we want the radius to be affected by the age. And also, we need to set the material. So let's use a set material node right here. Make a new material so that we can then get the colors if we want. But I will deal with that later. Let's just have the radius work. So let's use a set radius node, curve radius. And have it be radius. And then we'll use the age and a map range. Age and map range. To multiply the radius. So, yes, map range once again. We'll have it so that they start out very bright, and then they get smaller and smaller by the time they get to their end age of 50. I have a feeling that I did this wrong. So they're there, but they are extremely small. Ah, so I just need to not reference their previous age. Interesting. But we can see that this makes it extremely laggy. Not great. But it is what it is. Actually, what happens if these both have the same material? It kind of works. So, the good thing about this is when we use the distribute points on faces node right here, all the attributes get carried over. So the UVs get carried over, the normal gets carried over, the rotation, all that stuff. So we could take advantage of that. Speaking of taking advantage of that, I can just have this so that the radius is set and we don't need to reference the old one. Let's go and just move this over by a bit. Let's go and do that. Control J. There we go. So, to showcase that, let's go over to the shader editor. Not for this one, but for the original material here. And let's go and look at the UV map. So, if we take a look at the UV map, let's get the right named UV map. Wait, why is it not? Ah, that's why. If we get the UV map, we can see that it transfers to both of them. That's also because the instances are realized, so it just appears on the actual geometry, which is good. As we can see here, this looks really, really cool. We can put any texture that we want, like a checker texture, and it will work as intended. I guess the only downside, yeah, let's take a look at this again. And let's make it so that we can actually see the lighting. Yes, the textures are referenced correctly. But I want to go and make it so that the splines will go away from the object, so we need to go and store that normal data so that it will be carried along. So here I'll just make it normal and turn off caps lock. Okay, let's get that normal attribute and then put it into the velocity. It didn't recalculate. There we go. So if we just add this into the fold, this should work fairly well. Add. And we also might want to blur the velocity, because that might give better, like, more stringy results. Because it'll make it so that they... Oop. Dang, that's a bit more than I was expecting. So let's change this to 0.01. There we go. That's better. Yes. Okay, that's more like the show. Much better. Let's save this. There we go. Maybe it's always just one little change that makes it just click. There we go. One little change could make a world of difference. There we go. Okay, now that we have this, what else should I capture? Another thing that I'm going to capture is just a isCurve attribute. I just need this as a boolean so that we can differentiate in the shader between the mesh and then these curves. So just a little value right there, nothing too bad. Nothing too bad. And now all we need to do next, I'm starting to think that maybe I should make it so that, well, let's blur the velocity. So that's not just a, like, spline trace effect. As we should see here when it restarts. It looks a little bit more like the strings are interacting with each other, which is good. And another slight thing that we need to do is that I need to make it so that the velocity gets switched off if it's at the start position. Because we have it so that the velocity doesn't get applied at the start position. But that means when all of this happens, when the blur happens, it doesn't interact correctly. So here, I just need to go and make a switch so that if it's the start point, it'll switch to no velocity. Which means that we can get rid of this part, the selection right there, which should be good. So here we can see that that should give us slightly better results. Slightly. Okay. Not start point. Yeah, that's good enough. So now, the last thing that we really immediately need to do, I could turn down the resolution for speed, I hope. Yeah, that's a little bit better. Now we just need to make it so that the actual mesh disappears, according to the effect. This turns up red because we are looking at the geometry node splines. But if you want to have a method where it doesn't go red, and you can actually, just input whatever you want, you could just use an attribute node, and it'll just work the same. So I'm just going to replace that so that it doesn't keep appearing red, because that's a little bit annoying. So now I'm going to pull the gradient input, or attribute that we set on the original mesh. And here we can see that over here it's bright, over here it's dark. And if we use a greater than node, we can make it so that it disappears. So that's pretty good. And actually on the plus side, if we set it to be low enough, it won't appear on the original splines. So that's actually a plus. So let's go and plug that into the alpha, and then set this to alpha clip for both that and the shadow mode. And that should be good. So let's, again, look at this so that we can actually see the effect in practice. Oh, that looks good! Ooh, this is exciting! Nice. Okay, it's a little bit laggy, just because we have so many splines, but it speeds up as it goes along. We can also see it doesn't work on the foot part, unfortunately. I think that's just because the gradient didn't spread enough. So yeah, that's the Loki timeline erasure effect, I guess. The one last thing that I want to do is make it so that these don't start out as big, so they kind of fade into existing. So I can just make it so that, you know, it takes 3 frames for them to go to their end radius. So again, age, just plug that into there. If we do that, we should see it'll take... Actually, let's do 10 frames. So there, yes, they kind of grow into place instead of just appearing like that. Actually, maybe 5. It does... I don't want it to look like they're growing exactly, but... I could also make it so that they're thinner on the ends, which I think might give a more string-like appearance. Yeah, I can try that. So for that, I'll just need the spline parameter factor, and then multiply that with maybe a map range or a color ramp. Either one would do. I'll just use another map range because convenient. Set this to 1. And we want this to be the opposite direction. So that, okay, that looks more like tendrils rather than the Loki effect. So maybe I'll just do it like this. Nope. I'll need to look back at the effect, but I'm pretty sure the tubes were very harsh at the ends, which I think when I originally looked at the effect, I was like, huh, that's a little bit weird. But in hindsight, well, now experimenting with the effect, it's like, oh yeah, no, that looks a bit better. And also, I can change the radius from here, just in case these look a little too big. 0.05, whoop, 0.005. So it looks like the character gets absolutely atomized, which is cool. Alright, so yes, the effect, less than 30 minutes. This was able to be made in less than 30 minutes. That is surprising. Now, this does get more complicated if you, say, want the character to be moving and this effect to occur. Should be possible. You just need to make it so that this velocity here is Yes, it's inherited by its original mesh, which would be difficult to do, but I might have a way of doing that. Yeah, I'm not entirely sure. I would have to make it so that yeah, that's actually difficult. I would have to have a simulation to get the velocity of this object, and then somehow bind the current velocity to the start particles. I'm not sure how that would work, if I'm being honest. I would have to figure it out another time. That's the one thing with simulation nodes. Whenever you have something spawn on a mesh and you want it to stay on a mesh, it's difficult to do. But I've done something along those lines before, so I'm pretty sure I can do it. Is the shader okay? Like here, we can see that kind of... Not the biggest fan about that. I could make it so that it's alpha hashed, so that there's a little bit of noise. Yeah, we can do that, just so that's not a super harsh cutoff. So instead of using a greater than, I can use a map range. And I just need to make it so that it's below 0, so that the splines look better. So that the splines are not affected by the fading effect. So here, let me just... Okay, so more like this. So this is like 0.2. This is 0.1. Negative 0.2, my bad. So here, yes, so that fades into nothing where you're like, wait, is that, you can't really see where the Terminator is. Yeah, just a bit more of a fade so that you can't quite pinpoint when the mesh ends and the splines begin. Here we go. And if you want it so that this starts off earlier, like if you want it so that the fade is a lot more, but you don't want this the splines to fade into non-existence, you can just use the isCurve parameter that we set before. And then you can use a mix node, because we don't have the switch node in the shader editor, to switch between that being like that and that being set to 1. Oh wait, I did this the wrong way around. There we go. So that means that the mesh will have that applied, while these will always be set to 1. I could probably make it so that... No, it's fine. It's fine. That is a lot of splines. Now, if you wanted to do this in a game engine, shall we say, like Unreal, it would be a lot simpler, because they have very fast spline rendering techniques. But in Blender, these are all meshes, which is not great for speed. There is the hair... here, let's go into... There are the hair nodes, which spawn with... Here, where's the... Yes, the empty hair. With the hair nodes, they spawn in with actual thickness and stuff like that, so maybe I could try abusing that so that this works in that regard. Can I do that? Can I have it so... Oh, that would be interesting. I'm going to try that. Just very simply. Wait, why is that parented to that? We're going to have the... Why is surface deform? Oh, right. Yeah. Okay. Let's set that to that. And we don't want to mesh it. I want to see... It does work. Okay. So right now I'm abusing the hair rendering. Let's change this to strip so that we can actually see the... Okay, where's the thickness? Oh, there it is. Wait, what? Well, that's glitched out severely. Dang. Oh, no, wait, what? Why is that freaking out so bad? Maybe I found a bug. Maybe I found a bug. Because with the strands, those show up just fine. But when it's the strip method, which should look a whole ton better, it just really freaks out. Like, horribly. Okay, looks like I'll need to write a bug report about that. Because that is really, really bad. So if you try to edit a curve with geometry nodes with the simulation, it freaks out very, very badly. Good to know. Interesting. So if you want very fast hair rendering speeds, that's how you would do it. If Blender cooperated. I want to try that actually. Let me try to bypass the simulation node. And let's see how this looks. So we have very long lines, strands, we set to the strip rendering method. We don't want it to be rendered in this way. Let's just plug this into the output. So that's fine. Maybe it's just setting the radius that is freaking out entirely. Like, if we just keep the radius consistent, I think it might be fine. I think it's the attributes that are making it not work well. Because, yeah, see that? That's working better. Let's have this at 0.001. So, yeah, that is odd. And then we also just need to set the material. Very, very odd. But as we can see, this is in mostly real time. Mostly real time. And the endpoint scales to 0 with the hair curves. Interesting. Okay. So let's just use this normally. Let's not fiddle with the weirdness of the hair curves. Let's go back to the regular geometry method. That was a cool side tangent. Performance is actually... Okay, yeah, no. It is faster. It's like 4 times faster. So I wish that worked. Maybe it will, but I need to potentially write a bug report about that. Alright, so now that the effect is done, effectively, I should probably go and read the chat. And probably need to go and reset this gradient by a little bit, just so that it covers the entire mesh. Yeah. And this could be done to a room or basically any object, which is very cool. The only downside is that it's laggy. You're dealing with a lot of splines. They're all being handled on the CPU rather than the GPU. So it's going to be laggy. And here, yes. Let's go and... First of all, I'm going to just go and take a look at you so that we can actually see the gradient. So that it will go further. I'm just going to give it some wiggle room right there. Let's go and select you again, offset the time by a little bit more. So that's good. So in 30 minutes, I was able to recreate the timeline collapse effect from Loki. Nice. Not too bad. Not too bad. Should I put this up on my Gumroad page? This might be good for learning. The strands look really good in my opinion. Can you render them? Yes, you can. Whether it's strand or strip, you should be able to render them. It's just that the radius was really not liking it when I was affecting it with these parameters. I'm assuming that's a bug. But yeah, that's just a weird quirk with GeoNodes. It was almost like it was taking the average radius of all of them, then doing that. I could try doing it again, like I could enable it. If you're willing to watch some R&D with all this. Okay. Performance is actually not that bad when it's baked. And we can also, even though there are 20 control points here, if we want more resolution, we can do that in post by using the resample curve node or change set spline type, so that instead of it being poly, we can have it be Bezier. That should mean, if we look at the output, let's try to find one where it's like, oh, I can see some triangulation, like up here. If we set spline resolution, we can improve that. NURBS? Ah, NURBS, there we go. We can improve the resolution, which this will mean it's laggier when you go and mesh it. But yep, there we go. Yep, that's, yep, lots of geometry right there. Lots and lots. But if we're using the hair rendering method, I think it would be a lot faster. So, just pick your poison when it comes to that. Alright. I literally watched Loki like an hour ago. How did you know why I was watching? Ah, that was because I was watching Loki an hour ago. Yes. Alright. So, I guess we could just go and play around with the colors. Like, since you have the UV map here, you can put any texture on it. I wish I had a textured model, because that would show this a little bit better. Let's try a colored Voronoi texture. Let's have this just be 2D Voronoi, plug it into there. So here we should see that the colors get transferred perfectly. And this could be on non-human objects, so you could make, say, a purple couch just be eviscerated into the ether. Probably has the same topology as this one. Yep, And also, this could be an object with any topology. I just decimated mine for speed. Even though I think since this mesh only gets referenced for the points, it should be fine. But again, speed. Where's the camera? Let me go and switch this camera into good renderable stuff. We're at 40 minutes at the moment. I think I might go for a little bit longer, but the effect is done. So let's just put this at a good angle. Any other things you all would like to see with this effect? Because I can just let it play in the background. I will try having the empty hair object. I'll try that again. Let's go over to the geometry node and just skip over that so that we just have the curve. Then if we use, once again, where's the curve, empty hair. And then we just switch this out for the sim geometry node. Here, let's label this timeline collapse sim. Like, I don't know why that's happening. Is it just an attribute making it not like it? Like, it's fine as long as we don't actually set an attribute when it is the hair. Which I do not get. And also, let's make it so that the hair object has no parents, no reference. That's good. Just so that we can hide this for the time being. And as we can see, that works in real time. So I'm really confused as to why it's freaking out. Like if we plug this in, oh god. Let's go and just put one of these into here and see how that changes. Yeah, it doesn't like it. Oh no, wait, it does. No, it's fine. It's fine. No, it's not fine. Because it's acting on the entire object instead of just the curve. Maybe it's the spline domain that's making it freak out. So let's set this to point. Nope, same issue. I don't know, is it just me that's not understanding? Like, it's acting as if that parameter is on the entire object, as if all of it is one spline. That doesn't make sense. I'll write a bug report about that. I also need to check. Here, let me just try. I don't know. I'll do that off stream. Just trying to figure out the bugs and everything like that. So if we just have it so that there is no radius change and they just delete, performance is amazing. It's perfect. That's actually really good to know because some other projects I'm working on need attributes to render correctly. And if they don't, that's really, really bad. But yeah. Yeah, that's really bad. But it seems to be only the radius. So that is good to know. Actually, maybe I just need to set the radius named attribute. So here, if we connect this to the output, we should see a radius. Curve type, position. What are you? What data is on the hair? Sorry, I'm just doing some bug fixing at the moment. There's only a position attribute. Let's add in a radius attribute. Maybe that fixes it. Nope. Still collapses. And it's on the point thing, so it should work as intended. Come on, reload. Like, that should be... What if I were to add in the original geometry, even though it won't really matter? Would that fix it? I have a feeling that that might have worked. Nope, still broken. Okay, it's just a bug. Just a bug that needs fixing. Yep. Just a bug, a really, really bad bug. And the painful part will be that it might be a simulation nodes error. So that is unfortunate. We just use the strand method, that works just fine because the radius is not taken into account. It is really funny that with these live streams I always figure out bugs in Blender's coding. I'm just gonna hide the curves and go back to the plane once again, because, well, we don't need to worry about any bugs when it comes to that. Alright, let me just let that cache for a bit so that the replay will be better while I read the chat. Okay. If you're using care, which should be tied to the surface, if I'm correct, does that solve the follow movement issue? Probably not, because, well, it might. Because the hair is spawned in, and then it goes out of that dynamically. So, and I don't want all the hairs to deform with the object. So, no, it wouldn't work. One of the big problems with the, like, what's the curve one? Operations, deform curves on surface. It's a black box. No inputs, no customizability. So, people, like, I don't know what's actually going on inside of it. Which is really bad because it's like, oh, deform curves on surface. I would like to deform points on surface, or faces or instances by a surface. But since they just coded it like this, there's no option for that, which is really unfortunate. Because I guess one thing that you could do to deform points on surfaces, which is really messed up, is to convert your points to splines, like little splines like I did here, deform those splines and then convert them back into points on the output. Though I will say, I made my own deform curves on surface node, and that would work, just because I wanted one that wasn't a black box. So, yeah, I might try, I might bring that out and mess with it. Yep. And this, the funny thing is, with the input, the deform curves on surface, it's weird because it just doesn't follow the other geometry nodes conventions. I know that this uses the UV, the surface UV coordinate attribute as an input, but you don't see that here. It uses the position as an input, but you don't see that here. It uses quite a bit of data, like the rest position of the original mesh that's deforming as an input, but you don't see that. It's just a black box, which is not good. So, that's why I made my own. So that I can go and edit all of that dynamically. Okay, let me read all the chat because I have not read anything. Could you please make the sacred timeline for Loki? Maybe one day. Maybe one day. Actually, I kind of already made that effect a long time ago. Let's see. Now let me change the color so that the animation that's replaying is not just a static thing that is the same. Like, let's put in a noise texture. Two-dimensional noise, just plug it into the output so that we can see a nice gradient. All of those. So there's the gradient, and it just deforms as intended. Let's change the hue, saturation, and value of all those. If you have any questions about the effect, please ask them now, because we will be ending in about 10 minutes. There we go. Oh no! The guy got painted. Spaghetti. Let's see. Someone referred to me streaming early. That's just because I wanted to stream early. I had time. And apparently daylight savings happened, which I completely forgot about. I thought daylight savings was ending. Maybe that's the next cycle. It's no longer happening. Yeah. Could you change it so that they go in a certain direction? Yes, I can. All I need to do is change the apparent velocity. So if you want to add in, say, some gravity, which in this effect you probably don't want, but just for showcasing the effect. Here, let me also go and change this so that it spawns in much less splines. For speed, once again, there, it goes up. Actually, yeah, no, that also looks like the effect. But let's make it gravity by adding in the negative. Negative, there we go. There we go. So just, oh no, I'm falling. I'm being dissolved into time itself, which is cool. What else? I can make it so that they go backwards. Here, since there's not enough splines, you could see the gradient being moved very, very easily. So let's change that to be a bit less. That's cool. Let's try this on another object. Oh, that is way too much. And again, we can turn up the dampened amount so that this will look more like actual strings rather than just traced splines, because it looks better this way. So here, even though, yes, I need to turn this down because it seems like a bit too much of that was happening. Oh, the normal is too effective. If you turn up the, or turn down the drag, I guess, it's a little bit much. Actually, I'm not liking this as much, so I might go back to the other version. Yeah, the other version was pretty much perfect, as is. Maybe I'll increase the dampening by just a tad. But this one is a little bit less dynamic, but it's fine. Maybe I'll turn it up by just a tad. There we go, so we can see a little bit of movement. And I'll just turn down the noise by just a little bit. No, more noise is better, so no. What I previously had was the best. So let's swap out the object that this is occurring on. So instead of that, let's have just a plain old torus. Let's go and assign a start group right there, so we can see that happen. And then we just need to swap out the reference object. Now the one downside is I think this object might be a bit too big. So this will, yep, it's lagging. So let me scale down this torus by a significant degree. All the primitives are so big compared to an actual human. Like, that's an actual human's height. Maybe a little bit taller. But yeah, the primitives are just gigantic. And there we go. And again, let's just turn up the splines, make it so that there's 4 times the amount of splines, so that we can actually see that happen. Also, little caveat right here. If you want the normal to not look like this, where you can clearly see the faces, you just need to capture the normal and evaluate that on the point. So, capture attribute. You just need to capture the normal, whoop, not the face. We need this on the point domain. Just a little tip right here. Normal. We need to capture this beforehand, and then we just plug this here. It'll be inherited, but it'll be the interpolated normal. So here we can see that that little stepping issue is not a problem. Just a little quirk with geonodes. There are lots of quirks. Many quirks. There we go. So let's swap this out with the body again, and delete the old one here. And I think I'll try this out on a room, because I think that'll look really cool. But yes, that is the timeline collapse effect from Loki. And with that, we have 5 minutes left to the stream. Here we go, so this is opacity / alpha. Okay. Could it be done the other way around? If the face of the point is spawned and is moved away, it grows towards the face as well. Oh. It would be a different effect, but yes, that could work if it, well, actually no. The points would need to be bound to a part on the mesh. So, yeah, that, I'll need to figure out how to make the points bound to the surface, even if the character is moving. It's possible. I know it's possible, because I've done stuff like that before. It's just complicated. It's just complicated, because I would need to store the original mesh pose, the initial... Sorry, I got that all spun around backwards in my head. I would need to store the original rest pose of the object before the armature deforms it, and then also store the original rest pose of the vertices before they start moving. And then compare, basically bind them to the surface like that, and then inherit by a sample nearest surface node the current position of the moving mesh, which is a little bit complicated to do. But again, I've done it. I would just need to transfer it, but it would be a lot of math. It would be a lot of math. Okay. I want to do this Unreal. Do you have any Unreal tutorials? I do not do stuff in... Well, I do stuff in Unreal, but that's for work. I'm not too great at Unreal. So, no. I only mainly do Blender. This probably is doable in Unreal, though. I'm almost certain that can be done in Unreal. And in probably a better way, because everything in Unreal, when it comes to particles, is usually on the GPU. Okay. You should try it and make it... Wait, you should try it and make a geometry setup with it. With 4.0 AGX, it looks so sick. I'm not even sure... Am I using AGX at the moment? Where are the colors? I'm using Filmic. Okay. Switch to AGX, which... AGX... You should use AGX going forward. It's new in Blender 4.0, which you should use because it makes saturated lights look a lot better. It'll just make your scenes look a lot more realistic, as if an actual camera is filming it. So let's add in a light here. Oof. But yeah, let's change this to a really saturated color, really saturated red. If we switch this to Filmic, we can see that it changes it to orange, which is not accurate. That is more accurate to a really, really bright light. So yeah, that's that. That looks kind of horrific with the lighting being like that. Getting the lights to look right with these many thin things is probably annoying and difficult, but if you turn on contact shadows, it'll look better. Just contact shadows are not accurate. If I were to use Eevee next, though, or Eevee as it's being called, the next version of Eevee, with their new shadow mapping, I wonder how that looks. Answer, is it better? Let's check the light. Custom distance. Yeah, there's no more contact shadows with the next version of Eevee because they upgraded it. Oof. Nope, still bugged. There was a version in one of the alphas of Eevee Next where the shadows were super crisp when you zoomed in. I think they're using virtual shadow mapping with the new one. So when you zoomed in, it would adapt to what you would see on screen, which is good. But as we can see here, it is very much bugged. Maybe it's using the camera. So if I move the camera... Nope. Still bugged. They were so crisp in one of the updates, but then they really changed. Oh my gosh. Yeah, no, Eevee Next is very much bugged at the moment. Yikes. What is going on here? Whoa, that is trippy. Alright, we have 1 minute left, so let me switch to the version of Eevee that works. Alright. Alright. Are you interested in making the morph effect that King used when he explained the reason in the last episode of Season 1? Oh, the kind of deforming... I mean, that's just a interpolated remesh. Like, you take an object, fill it with points, and then take another object, fill it with points, interpolate between those two positions, remesh it, stick a, like, stone, gold, or texture over it, and then you're good. Not too complicated, just extremely laggy because you have to voxel remesh thing. Okay. How to understand math and geometry nodes. Practice and looking at the documentation and looking at tutorials. Like here, it's mostly attributes. So here I have a isCurve attribute that I set, and then we have a gradient attribute that I set. You know, you just do the math. You're playing around with colors. That's how I like to think about it. Like with all this math, I'm just taking like, oh, what's the current position? I'm just taking the velocity attribute, which is a very low color, as we can see here, and manipulating that color, taking the normal color, which let me turn this up, manipulating that color. That's how I'm seeing it in my head. Every time I'm looking at an attribute, I'm visualizing the color, which actually that looks really, really cool. I should probably go and show that in the shader editor. Probably. Though the funny thing is, if I do output the normal as an attribute, it'll show up on the curves, but not the original object, because I did not store it on the original object. Actually, I could do that, though. Just for simplicity's sake. I just need to store the normal before that, and it would solve the, Here, let me... No, why is Control-C, Control-V? There we go. I just store the normal before that part, and then it'll be the interpolated normal. There we go. The benefits of the store named attribute node, and also nodes doing sharing of data, which we cannot share all the data with our current node setups because we can't repeat things for every single attribute in a list, in the object's data list. So yeah, that's a little unfortunate, but it is what it is. So here, again, if we look with the attribute here, the normal attribute, we should see... Oh, why is it not appearing on the geometry? Huh. Oh, I know why. That's because this geometry, it doesn't have the normal set on it, so it's not visible. While it's set on the geometry that this is referencing. So, yeah, unfortunately it's not visible, but we could just go and reference the, you know, the actual geometry normal, and then just switch between that and then this normal when we want. But yeah, there we go. So thank you all for watching. I think that is all of the questions. But yeah, this was a very cool effect to work on, and it didn't take too long. Like half the time was playing around with the bugs in Blender. But yeah, that radius bug I really need to check out because that could be really, really bad for other projects I am working on. So yes, thank you all for watching. Enjoy the spaghetti. And let me just check the last comment. How hard would it be to make this capable of morphing into a new object, like leaving the strands out of the character as they are, but navigate their way to a new mesh? That would be difficult, just because of the logic of it. Like, I could make it so that, okay, I'm pointing at the screen, but you can't see me pointing. If you take this part, because we can select the endpoint and say, hey, endpoint, go to another point on another mesh. We can do that, but it's like, okay, what order should we go in so that the splines don't crisscross each other? Do they go to just the vertices of an object, or do they go to like a randomly distributed point on a face? What would the order be, and so on? There are just a lot of weird mathematical and logistical quirks of that. It's possible, yes. Is it easy? No. But yes. Thank you all for watching. I will see you all next time. Have a good one.